Azure Service Bus, Advantages versus Disadvantages for Cloud Learners and System Designers. Azure Service Bus, ASB, is a fully managed enterprise messaging broker built for mission-critical communication in distributed and event-driven systems. Its value becomes clear when systems need guaranteed delivery, decoupling, resilience, and governance at scale. But like every technology, it also brings trade-offs. Let's examine both sides deeply so you can use this for lectures, architecture decisions, or interview preparation. Advantages of Azure Service Bus. Enterprise-grade reliability and guaranteed delivery. Azure Service Bus ensures that once a message is accepted by the broker, it is never lost. It persists messages to highly available storage and maintains them until the consumer confirms completion. This delivery guarantee is crucial in domains like banking, insurance, healthcare, e-commerce, government transactions, logistics, and industrial IoT command systems, where message loss is not an option. It also supports at least once delivery, and when combined with duplicate detection, it can behave like exactly once processing, preventing repeated side effects. Even during transient failures, network disruptions, or consumer downtime, messages remain safe, enabling eventual consistency and resilient workflows. 2. Loose coupling between system components. Service Bus decouples producers and consumers so that they don't need to be online simultaneously. This removes hard dependencies, improves fault tolerance, and allows independent scaling. For example, a web API can push messages into a queue and return instantly without waiting for downstream processing. This protects the front end from back-end failures and helps systems stay responsive under load. It encourages asynchronous design, which is a cornerstone of microservices, serverless, distributed job processing, and event-driven architectures. 3. Flexible messaging patterns. Queue plus pub/sub. Azure Service Bus supports both point-to-point queues and publish-subscribe topics with subscriptions. Queues allow one consumer to process each message, supporting competing consumers for load distribution. Topics allow multiple independent subscribers to receive message copies, enabling architectures like fan-out notifications, event broadcasting, data routing, and multi-service workflow coordination. Subscriptions also support filtering rules, meaning services receive only the messages relevant to them, reducing processing noise and improving efficiency. 4. Message ordering using sessions in distributed messaging. Message order can break workflows. Azure Service Bus solves this using sessions. Messages with the same session ID are delivered sequentially to the same consumer. This is extremely useful for transaction sequences, event replay, FIFO workflows, ordered command execution, or scenarios where state consistency depends on order. 5. Scheduled delivery and message deferral. Azure Service Bus allows scheduling messages for future delivery using scheduled and queue time UTC. This supports reminders, delayed workflows, time-based triggers, appointment notifications, retry timing control, and deferred job execution. Message deferral enables consumers to pause processing temporarily and retrieve the message later using its sequence number without losing it. 6. Dead letter queue for error handling. When a message fails repeatedly or expires, it is moved to a dead letter queue, DLQ, instead of being deleted. This is critical for debugging, replaying, or storing failed messages for manual or automated recovery pipelines. This feature makes ASB much more advanced than basic storage queues. Security. Your identity integration. ASB supports TLS RJA encryption, SAS tokens, RBAC authorization, and Azure AD managed identity authentication. Managed identity removes the need to store keys in code, which increases security posture for production workloads. Service Bus also supports private endpoints, VNet rules, and IP firewalls, making it compliant for regulated industries. Transaction support, ACID messaging. Service Bus supports multi-operation transactions. This means systems can receive a message, process it, and publish new messages atomically. If one part fails, the entire transaction rolls back. This is crucial for financial operations, inventory updates, billing systems, or multi-message workflows requiring atomicity. 9. High scalability and large message throughput. Azure Service Bus is built to scale. It supports auto-load balancing across multiple consumers, large volumes of messages, and regional namespaces. It can also handle large message sizes, up to 256 kilobytes in standard, 100 megabytes in premium using AMQP, making it suitable for enterprise workloads. 10. Excellent monitoring and observability. Service Bus integrates with Azure Monitor, log analytics, application insights, metrics dashboards, diagnostic logs, alert rules, and message tracking. This gives teams visibility into throughput, latency, active message count, scheduled count, DLQ size, failed deliveries, and consumer health. Shree supports hybrid and cross-service integration. It supports AMQP, HTTPS, SDK clients, Net, Java, Python, Go, JS, making it great for on-prem Java cloud communication, multi-language microservices, and enterprise integration patterns. Disadvantages of Azure Service Bus. Higher cost compared to basic queuing services. Although fully managed, ASB can be more expensive than Azure storage queues or other lightweight brokers when used at high throughput. Premium tier, which is recommended for production in regulated workloads, includes dedicated resources and can increase cost further. If a system only needs simple queuing without advanced guarantees, Service Bus might be overkill. 2. Not ideal for real-time streaming or event analytics. Azure Service Bus is designed for workflow messaging, not high-speed event streaming. It does not match Kafka or event hubs for real-time telemetry ingestion or log streaming. If your system needs millisecond-level real-time analytics, ASB is not the right fit. 3. Regional namespace scaling requires planning. Each namespace is bound to a region and throughput unit. Global scaling across many regions needs multiple namespaces or geodisaster planning. This introduces architectural complexity compared to globally distributed streaming platforms. 4. Session ordering requires single consumer discipline. Sessions guarantee order, but only one consumer can process a session at a time. If sessions are misused, they can reduce parallelism and slow throughput. This demands careful consumer design and session distribution planning. 5. Requires good governance for TTL and retries. If TTL and retry policies are not configured well, queues may grow unexpectedly, increasing storage footprint and operational noise. Systems need lifecycle rules and monitoring to prevent message pileups. 6. Debugging. Distributed messaging adds operational complexity. Messaging systems require teams to understand DLQs, retries, abandoned messages, consumer locks, message settlement modes, correlation IDs, tracking, and observability. This learning curve is higher than synchronous REST APIs. 7. Vendor lock-in. Due to deep Azure ecosystem integration. Since ASB is tightly integrated with Azure Identity, Monitoring, Policy, Networking, and Governance, migrating to non-Azure brokers later may require re-engineering. This can introduce long-term platform dependence. 8. Message size limits in standard tier. Although Premium supports 100 megabytes messages over AMQP, standard tier only supports 256 kilobytes. Large payload systems may need blob offloading, which increases system design work. 9. No built-in message replay like streaming brokers. Unlike Kafka, Service Bus does not support log-style replay of historical messages as a first-class feature. Replay requires manual DLQ or message archival strategy. 10. Requires consumer availability for peak load processing service. Bus distributes messages across competing consumers. But if consumers are under-provisioned, backlog increases. You must still design consumer scaling properly. Final takeaway for learners: Azure Service Bus is excellent when systems need guaranteed delivery, sequencing, routing, scheduling, dead lettering, identity security, and enterprise governance. But it is not the best choice when you need low-cost simple queues or real-time event streaming. The decision depends on workload type. Workflow messaging equals Service Bus. Streaming analytics equals Event Hubs/Kafka. Cheap basic queue equals storage queue.